And presentation is open for questions in both in person or online. So if there are questions online, please ask. If you are not sure how to verbalize it, you can type it in the chat line. And just to start, okay, Professor Kulina, I think there is a question. You were raising hand?
Yes. So can you go to the slide?
We can't hear you.
Where you're showing your two cases.
Okay. They should be here. Just a second, we don't hear. Let's try to. Let's try once again.
Can you hear me now?
Yes, perfectly.
Oh, okay. So don't need them to type the question. Can you go to the slide where you're showing the first animation? Yeah, the very first one this one. Can you again explain why the red line for the case when you have this excited state being with offset in energy, why it is curvy, having many maximums and minimums, while when you have no offset, it is just a single maximum there.
Perfect. So where we have these mini curves is the distribution of the electron probability. Since this from getting from here to here, the energy, the activation energy needed to get all the way over this was too high for all the electrons to get over. And so we can see that the electrons that did get over, these two had high enough energy to get over, but this one did not. And in where they're both set to the same, all the electrons did have the right amount of activation energy to actually get through that first one and complete the reaction.
So you're saying that number of curves corresponds to the number of electrons, or I didn't get the answer. I understand that the energy is different, and you have different rates of transition.
So,
but you still didn't answer the question, why is it curvy?
So what I think,
if the offset would be smaller or larger, you expect more curves or less curves?
So
it really depends on the offset energy in these two parabolas in these two states?
So with the energy being higher or lower, you expect more curves because only some electrons will be able to get over this barrier.
Let me just add a comment. We are speaking about one electron.
One electron, yes.
Maybe you want to direct the discussion into the number of eigenstates in the red parabola.
Okay. So let's rephrase this. So in this first one, we can see the electron only going into this first eigenstate. And in the second one, since the energy offset was higher, we can see it actually transferring to 4 eigenstates.
Okay, actually, the curvy line just corresponds to the higher energy state where the electron goes from your initial to the excited state in the second parabola, right?
Okay, yep. So that will, this wants to move here.
Yeah, because if it's just 0 to 0, kind of, your first state, if it goes directly from first to first, you should have only one peak, right?
Okay, so that would correlate with this one here where we see all 4. Correct?
Okay, thank you.
Okay, are there more questions to Zane? Checking the chat line. We do not see echo one.
Okay.
So, and it is a serious one. If you do not have immediate answer, do not panic. It's like heavy question. So you and maybe you can show the slide with forward with your dependence on the energy. Yes.
Okay.
So you are exploring different values of energy offset between electronic states, and you are finding the rates, yes, which in some aspect agree, in some disagree with prediction of Markov theory.
Yes.
But how would you recommend to perform an experiment to explore these different points, especially like how people were implementing Markov theory? They were taking different molecules, each of which charge transfer molecules correspond to different places on the Markov spectrum. But what would you do if you want to see different regimes for the same molecule or the same object?
So in that, you could actually add your initial momentum, your P naught. No.
How to change energy of this? So how to shift the parabolas?
I was trying to.
Just think creatively how you can change the energy of the charge transfer state, which has a dipole.
So you could use, instead of the lead or hexabromo lead -4, you could use the hexabromo lead -2.
Okay.
And that would.
Let's try it once again. So these objects are dissolved in solvents. Yes. And solvents can have different polarity. Yes. So how would polarity affect the offset of energy?
So you would change the solvent's polarity? Okay. Looking for that one online.
Okay, last chance to ask question to Zane. Let's check Okay, no one is having additional questions to Zane. Let's thank him for presentation and great answers.
Thank you.